In my last video, I told you that we will see the distinguish between ray optics and the wave optics. Now, in the last video, you can see the last line of the last video was light is an, I'm writing the point again, light is an electromagnetic wave which belongs in the visible region having wavelength from 7,000, that is from 4,000 into 10 power minus 10 meter, if you remember this is called Armstrong, to 7,000 into 10 power minus 10 meter or Armstrong or 7,500. Now my dear, this was my last statement in my last video given to you that light is an electromagnetic wave. It belongs to the visible region and the range of the wavelength in this region was 4,000 into 10 power minus 10 meter, that is 4,000 Armstrong, to 7,000 into 10 power minus 10 meter or 7,000 Armstrong. My dear, why I have written this line once again in this video? Because this is the line, this is the point which will make us to understand the distinguish between ray optics and wave optics. Look at it. Here I have written the wavelength in the order of 10 power minus 10 meter. Try to understand 10 power minus 10 is so small. It's very small wavelength. And therefore this is to be understood because this only the statement which makes us to understand ray optics and wave optics. Now let's start. Now this is a time where I should give you a distinguished point under ray optics and wave optics. Now ray optics, when I say, as I said that in ray optics we are discussed with the light, right? Now when we say, even in wave optics also we discuss with the light, but here we are discussing the light move in a straight line. And here we discuss that light has a wave nature. So this we can write in the statement in the distinguish that in ray optics the light is a straight line wave. But here in wave optics the light is in the form of wave. That is okay. But what is a very important distinguish is that in the ray optics chapter, in this topic, we will going to take the object. Because here also we require an object, here also we require an object. Because my dear, how will come to know that there is an object unless and until we are talking about light fall on that? You know from class 7th, 8th standard only that we can see the object because of light. Because light fall on the object and we can see, yeah, there is an object. Okay, so here in both the topics we have a concept of object. Now what is in ray optics? The size of the object my dear, here I mean to say ये ऑब्जेक्ट कौन से ऑब्जेक्ट की मैं बात कर रहा हूं जिस पे लाइट फॉल करेगा, मैं उस ऑब्जेक्ट्स की बात कर रहा हूं ये चैप्टर में लाइट विल फॉल ऑन मिरर, light will fall on spherical mirror, light will fall on plane mirror, light will fall on concave lens, convex lens. Am I clear? Light will fall on concave mirror, light will fall on convex mirror. These are the object where the light, on which the light will fall. My dear, you can imagine yourself that the size of the object, the size of the lens, the size of the mirror, the size of the plane mirror, the size of convex lens, my dear, the size of these objects is large as compared to the wavelength of light. as compared to wavelength of light. This is the very important, and how you come to know that wavelength of light, sir, is small? You can say other way around. When I write the size of the object is large as compared to wavelength of light, मैं उल्टा भी बोल सकता हूँ कि the wavelength of light is small as compared to the size of the object. I can write reverse also, that the wavelength of the light is small as compared to the size of the object. And you know, and because of that, here we are studying mirror, we study lens, we study prism, we study simple microscope. See, the object which I am writing here, जिस पे लाइट गिरने वाला है, जिस पे लाइट फॉल होने वाला है, उस ऑब्जेक्ट को आप देखो, मिरर है, लेंस है, प्रिज्म है, सिंपल माइक्रोस्कोप है, कंपाउंड माइक्रोस्कोप है, ऑल माइक्रोस्कोप आई मीन, कंपाउंड माइक्रोस्कोप, even telescope, this all, you can see these objects, these all are objects on which the light will fall, and the size of these objects are very large as compared to the wavelength of light. Please try to understand. इसका मतलब the wavelength of light in the ray optics chapter, the wavelength of the light is small as compared to the size of the object. However, and therefore here in this chapter we discuss mirror, we discuss lens, we discuss prism, we discuss simple microscope. ये सब concepts होते हैं जहाँ पे objects की size बड़े होते हैं as compared to the wavelength of the light which is going to fall on them in the chapter of ray optics. But in the wave optics, this is an important one. In the chapter wave optics, now from this topic, you sure about it that these two chapters are categorized on the basis of two concepts. One, the size of the object, and other, the wavelength of the light. I repeat, these two concepts, ray optics and wave optics, are distinguished on the basis of two things. One, the size of the object, and second, the wavelength of the light. My dear, ray optics के chapter में what we studied, the wavelength of the light is very small as compared to the size of the object. या उल्टा बोलो, the size of the object is very large as compared to wavelength of the light, and therefore in the chapter of ray optics we will study mirror, we will study lens, we will study prism, microscope and all that. However, in the case of wave optics, the size of the object and wavelength of light are comparable. Comparable means they are almost same. They are almost same, and this is the reason why I said try to understand. This is the two chapter. एक चैप्टर ऐसा है जहाँ पे हम पढ़ने वाले हैं कि ऑब्जेक्ट के साइज बड़े होंगे और लाइट का वेवलेंथ कम होगा, और ऑब्जेक्ट के साइज में आपको मालूम है, यू नो दैट वी आर टॉकिंग अबाउट लेंस. ऑफ कोर्स लेंस का साइज यू कैन सी, and on which the light will fall. You can imagine what is the wavelength of that light which is falling on lens. Of course, the size of the lens will be bigger than the wavelength of the light which fall on it. This you should aware about. But over here in this chapter भी हम लाइट के बारे में ही पढ़ रहे हैं, वेव ऑप्टिक्स में हम लाइट के बारे में ही पढ़ रहे हैं. बट कैसे पढ़ रहे हैं? That the size of the object and the wavelength of the light which we use are in comparison. They are comparable. We can compare them. They are almost same. Nobody is bigger or nobody smaller. They are almost same. And therefore, in this chapter, we use a object like pinhole. Cardboard में we do the pinholes. Cardboard में हमने बचपन में when we were a small one, as far as I concerned, मैंने किया था. In cardboard, when we put one hole and we keep the lamp behind it, light will come out through that hole. Look at the size of the hole. That size of the hole is so small, and it will be get compared with the wavelength of the light. So please try to understand, my dear, this is very important कि हम ये chapter में क्या पढ़ते हैं और ये chapter में क्या पढ़ते हैं. So here you will study the concept of pinhole. You will study the concept of slits. Right? When I do my finger like this, you can see the gap in between these two fingers. Right? Like this, I am looking you. That is called slit. You can see the size of the slits, and we can call this as slit width. We call this as slit width. Am I clear? So here in this concept, pinhole, slit width, this kind of an object being used. There in the wave optics, I am not going to use concave mirror or convex mirror. Please try to understand. In the chapter of wave optics, nowhere we are writing that I have used concave mirror, I have used convex mirror, I have used convex lens, I have used concave lens. No, sorry my dear. There the size of the object are like, the objects are like pinholes. We are putting the hole, we are putting the point in the cardboard, that become our object on which the light will fall. और फिर वहाँ से light will proceed further. So there we are using pinhole, there we are using slits. We are using slit. Right now I am showing with my finger that how the slit looks like. You can see there is a gap between these two fingers, and that is called slit. And if I increase this, that become width. Now you see the width is increasing. Am I clear? So my slit width concept will be coming under wave optics. So this is what is the basic very important difference. Ki sir, in wave optics the object size is large as compared to wavelength of the light. And the objects are lens, mirror, prism, microscopes, etc. Whereas in wave optics, the size of the objects is more or less, it is comparable with the wavelength of the light. And therefore the size of the objects we have taken the concept of pinhole, the concept of slit width, and therefore we have the experiment so-called Young's double slit experiment from our single slit width diffraction. This kind of a thing we are going to study in the chapter called wave optics. We will not going to study anything about concave mirror, convex mirror or something like that there in the chapter of wave optics. This is one very important distinguish that is related to the wavelength of the light. And this is the reason why I have given you a brief discussion with the electromagnetic. So that students should aware that the light ka wavelength is, is in 10 power minus 10 meter. You should aware about it that the wavelength is very small. On the basis of that, we have categorized the two chapters. एक में हमने ऑब्जेक्ट के साइज को बढ़ा रखा है वेवलेंथ ऑफ द लाइट से, वो सारे चीजें हम रे ऑप्टिक्स में पढ़ेंगे. और वो ऑब्जेक्ट के साइज है कॉन्वेक्स मिरर, कॉन्वेक्स लेंस, कॉन्केव मिरर, कॉन्केव लेंस, प्रिज्म एंड माइक्रोस्कोप एंड सो ऑन. और एक में द साइज ऑफ द ऑब्जेक्ट एंड द वेवलेंथ ऑफ लाइट आर ऑलमोस्ट कंपेरेबल in their sizes. And therefore, we are using the objects in the wave optics, not concave or convex or prism. We are using there a kind of a thing that is pinhole. That is, we are putting a pins in cardboard and we are passing the light through the pinholes. We are passing the light through the slit kind of a thing called slit width. Am I clear? And because of this, we can study the phenomena such as interference, diffraction and polarization in the topic so-called as wave optics. Now apart from this, my dear, the second distinguish you can write in ray optics, the chapter ray optics could not discuss the phenomena. The chapter ray optics or the chapter geometrical optics or the topic geometrical optics or ray optics could not discuss the phenomena of, if you remember, the phenomena of, that is nothing but interference, diffraction and polarization. So these three phenomena, don't write that which phenomena takes place. Write other way around. No? Write that the phenomena such as interference, diffraction, polarization cannot, could not take place in ray optics. And you know why it cannot take place in ray optics? Because the size of the objects is large as compared to wavelength of light. Or you can say the wavelength of light is very small as compared to the size of the object, and because of that, my dear, I cannot able to explain the phenomena of interference, diffraction or polarization in this topic. But here the point number 2 you can write the phenomenon of interference, diffraction and polarization are observed in the chapter or in the topic wave optics, which is due to, I have taught this part to you in my first video, these are due to the wave nature of light. So my dear, this is a basic distinguish where you should take care of this, that sir, in ray optics we will deal with those things where the object size is large. I'll repeat this again and then I will start with my refraction topic, that is refraction from the plane mirror. So what is important point, that in ray optics, sir, we will study those things where the size of the objects is large as compared to wavelength of light. And the objects which you are taking in the topic is concave mirror, concave lens, convex lens, prism, etc., microscope and all. Whereas in wave optics, the size of the object, right? The size of the object is as comparable, it is incomparable with the wavelength of the light. And in that chapter, wave optics, we are using, because of that, since the object size should be small, wavelength of light is small. And because of that, we are using pinhole, we are using slits, we are using the narrow slits, that is called a very small narrow, jiska width is very less. And therefore it is said the wavelength of light is compared with the size of the objects, is incomparable with the size of the objects. And second thing, my dear, the phenomena which we cannot observe in ray optics and the phenomena which we can observe in wave optics can be distinguished. You can write that the phenomena such as interference, diffraction, polarization, this all cannot be explained in the topic of ray optics. But these phenomena are explained within the topic of wave optics, and I told you the reason is wavelength of the light and the size of the object. So if you wish to write anything from the board, you please continue writing. I will take my next part, that is my next part is the refraction of the light. Because you all know that I am dealing with the chapter ray optics. I just wanted to give you the distinguished point because many of you are not clear. So I just wanted to give you the distinguished point between the ray and the wave. Why we have decided the two different chapters. Because of that, my dear, I have given you this concept. Now, truly speaking, I will talk on ray optics. Now I am ending with the wave optics. We will discuss this wave optics after the completion of the chapter. So now I will begin with the ray optics. Under ray optics, you all know that the very first topic is refraction. Am I clear? So I will begin with the topic of refraction in short moment of time. If you wish to write anything from the board, please you write now. So my dear student, now as we know that ray optics is the one where the size of the object is large as compared to wavelength of light, and in wave optics the size of the object is incomparable with the wavelength of light. In short, my dear, these things as written in a book other way round, that ray optics I am giving one more point about it, that the ray optics, because I started with the ray optics. So the ray optics deals with particle nature of light. Particle nature of light. And what do you mean by particle nature of light? That if light is a particle, it travels in a straight line through an object whose size is large as compared to its wavelength. So ray optics deals with the particle. Please take care, this is deals with the particle nature of light. As I said, matlab light is, you all know that from small class, light consists of small tiny particles. This was given by Newton in his theory called Newton corpuscular theory. In biology also, bache, you are studying corpuscles. What are corpuscles? Small tiny particles. And in the chapter ray optics, we will discuss with the light is a small tiny particles. Whereas in wave optics, we say light is a wave nature. वहाँ हम ये नहीं बोलते हैं it is a particle. We say it is a wave nature. In that chapter, we came to know that, oh God, light possesses the dual nature. दो nature है light के पास. One is the particle nature, and other is the wave nature, which we discuss in the next chapter. So in broad, I hope now with my video you all understood that sir, ray optics we will discuss the particle nature of light, in wave optics we discuss the wave nature of light, or other way around. I have given in my earlier videos that in ray optics the size of the object is large as compared to the wavelength of the light used. And in wave optics, the size of the objects are comparable with the wavelength of light, and this is the reason why we use a pinholes, we use the slit width in the chapter wave optics. Our diffraction, our interference will take place either through a pinhole or either through a slit width. It is a narrow slits. So ray optics is dealing with the particle nature. Let's begin with this, that it deals with the particle nature, where it explains the phenomena, and the phenomena are refraction. The very first phenomena is refraction in the chapter. And this phenomena is, again, every time I will keep on saying this, that this phenomena of light is possible due to particle nature of light. Is possible due to particle nature of light. But if I ask you diffraction is not due to particle nature, it is due to the wave nature. Am I clear? So please take care of this part, that what is particle nature and what is wave nature. Chapter 9 is only the light with the particle nature. Chapter 10 is the light with the wave nature. Am I clear? And this, what in the other way around some of the books say, in ray optics we deal that light travel in a straight line, and therefore we deal with the rectilinear propagation concept, we deal with the reflection, we deal with the refraction, we deal with the dispersion. But interference and diffraction cannot be dealt with the help of particle nature, they are dealt with the help of wave nature. Why I am saying this again and again? Because students should aware about this is a very important concept, that light has a dual nature. It exists in particle as well as in wave form also. This is very important that students should aware. And therefore, let's start with the first part under ray optics. After writing this, that the ray optic deals with the particle nature, the very first topic, the very first phenomena which will be studied due to particle nature is refraction. Now under refraction, my dear, everybody know that what is refraction. Everybody right now in class 12, because from class 7th only, 6th only we know that what is refraction. Refraction is nothing but bouncing back of the light in the same medium. Bouncing back. मतलब light यहाँ पे incident हुआ, see, there is a surface, this surface is called reflecting surface. The one which help in reflection called reflecting surface. So this is the incident ray and this is the refracted ray. You can see in my diagram, this is incident ray and this is refracted ray. So what is happening in refraction? The light bounces back. The light bounces back in the same medium. I mean to say, after striking the reflecting surface, light वापस से उसी medium में bounce back हो गया. I hope it is clear. So in this class of 12th, everybody can define what is reflection. It is bouncing back of light. I repeat, and right here, it is bouncing back of light in same medium. I hope it is clear. And my dear, when I talk about reflection, you know from beginning, after knowing the definition, sir, it is bouncing back of the light in the same medium. Some of the books say the light travel in the opposite direction in the same medium after reflection. But instead of saying opposite direction, you say that it is a bouncing back, a very sweet line. It is a bouncing back of light in a same medium. You can add more line, more word, after striking the which surface? Reflecting surface. This is a short and pure definition of reflection, that the reflection phenomena is the bouncing back of light in the same medium after striking the reflecting surface. Reflecting surface को strike करने के बाद light bounce back in the same medium. Okay. Now, my dear, after doing this concept that what is reflection, you all know that reflection takes place from various surfaces. Various surface. For class 12th, it is not difficult to know what are the surface through which the reflection takes place. Now these surfaces are plane mirror in your syllabus. This is plane mirror. You can take as the concave mirror. You can take as a convex mirror. The various mirror, from class 10th you studying this topic, the various mirrors help in reflection. And we have the two category of mirror. One is a plane mirror and other is a spherical mirror. So first of all, I will teach you the reflection. This is the definition of reflection. First of all, I will teach you the reflection from plane mirror. Reflection from plane mirror. And my dear, with this topic, a small topic I am writing on the board to explain you the laws of reflection. Everybody, I hope, they know that what are the laws of reflection. But with the concept of plane mirror only, I will explain the laws of reflection. One thing we should note down, that laws of the reflection either explained by plane mirror or can be explained by spherical mirror. कोई problem नहीं है, laws remain the same. Laws of reflection will not change by changing the nature of the mirror. I repeat, laws of reflection does not change by changing the nature of mirror, whether the mirror is plane or whether the mirror is spherical. Am I clear? So I wanted to explain the laws of reflection also simultaneously with one diagram of reflection from plane mirror. You can see here on the board that, for example, my dear, here I have taken the plane mirror in front of you. And this plane mirror I kept horizontally. You can see in my diagram, the plane mirror I can kept vertically also, like this. But this plane mirror I kept horizontal over here. Am I clear? Normal diagram, everybody aware about this diagram. And for example, my dear, say there is an incident ray traveling over here. You can see in the medium, no doubt here I assume that there is an air through which this light is coming. I hope it is clear. So this ray, I give them a name PQ, and this PQ become incident ray. You know this. I just briefing you because you are doing the basic things with me, and then so that you will be cope up with what are the hierarchy in the class 12th. So this is the incident ray PQ. And my dear, you all know that we don't only want an incident ray, we have to measure incident angle, and for that we have to draw the normal. So let us draw the normal. Now how to draw the normal? Everybody knows the normal language means perpendicular. Perpendicular to the surface. If my surface is like this, what do you call this surface? This surface is called refracting surface. Okay, so if my surface is horizontal, plane horizontal like this, how should we draw normal? The normal is drawn perpendicular like this. I am drawing with the dotted line. This is the normal I have drawn perpendicular to the horizontal line. If I wish to draw the normal for this diagram, this will be perpendicular to this. This is the normal. But it doesn't mean it should be in the center only. I can draw perpendicular anywhere on the surface, on the given surface, and that become normal. So here I have drawn the normal by drawing perpendicular, and now I can write here, this is the angle of incidence, denoted by I, angle I. So what is angle of incidence? You know from class 6-7 that it is the angle between incident ray and normal. So angle of incidence, in class 10th you have studied this. Similarly, my dear, I said the refraction phenomena is the one where the light bouncing back in the same medium. So here what happened? This light will fall here at point Q on the reflecting surface, and it will be bounces back, जिसको हम refracted back बोलते हैं. My dear, bounces back is only called reflected back. So it is reflected back in the same medium, जहाँ से light आया था वही medium में it reflected back, it bounces back, and this ray is called reflected ray, denoted by say QR in my diagram. So that the refracted ray and normal will make another angle called angle of refraction, denoted by R. So now here you can see I have drawn incident ray, I have drawn reflected ray, I have drawn normal ray. In all, in my diagram there are three rays. They are named as incident ray, normal ray and reflected ray. From the diagram I am very sure the very first law we all know, but very first law of refraction is, here I am writing reflection from plane mirror, but the topic is laws of refraction. Because I think it is very important to show the laws of refraction first, either by doing with the plane mirror or either by taking a reflection through the spherical mirror. So the very first laws of refraction with the diagram, मैंने plane mirror का use किया है laws देने के लिए, मैं spherical mirror भी use कर सकता था. Am I clear? But since I am teaching you the refraction from plane mirror, I thought I should give the laws here only. So the very first law is angle I is equal to angle R. That is, the angle of incidence is equal to the angle of reflection. This is the first law. And the second law, you can see in the diagram. My dear, how many rays are there in front of you? I hope 3 rays. What are the name of these 3 rays? Incident ray, normal ray and reflected ray. Now my dear, these 3 rays are in the same plane. You can see, ये सब के सब top में है. इंसिडेंट रे भी ऊपर है, नॉर्मल रे भी इसी प्लेन में है और रिफ्लेक्टेड रे भी प्लेन में है, उसी प्लेन में तीनों है. And therefore we say they are in the same plane. Can you see refracted ray downside? No. Can you see the normal ray downside? No. जहाँ इंसिडेंट रे है जिस प्लेन में, उसी प्लेन में नॉर्मल रे भी है, उसी प्लेन में रिफ्लेक्टेड रे भी है. And therefore, my dear, the second law become incident ray, normal ray and reflected ray are lie in the same plane. You see, these are the plane. I'm moving my hand. This is the plane. This is the plane. सब के सब ये plane में है. Incident ray, normal ray, reflected ray, all are in this plane. Nobody is at down plane or left plane or right. All are in one plane. You can see. And therefore we said that the incident ray, normal ray and reflected ray are lie in the same plane. This is one thing. Second is that एक और point note करने जैसा, you please note it down, that ये तीनों ray, incident ray, normal ray and reflected ray are lie at the same point of incidence. All these 3 point का incidence क्या है? Incident ray PQ है, yes or no? So what is the point of incident? Q. Q is the point of incident. What is the point of incident for normal ray? Q. Q is the point of incident for the normal ray also. What is the point of incidence for the reflected ray? Again Q. Q is the point of incidence. So this 3 rays has the same point of incidence in the diagram. And therefore, in second law, when you write the law for reflection, second point, we write this way: the incident ray, normal and reflected ray are lie in the same plane. Are lie in the same plane. You can see in the diagram, all are in the same plane, top plane. Incident ray, normal ray, reflected ray, all are in the top plane, one plane. You can see. I'm moving my hand. So they lie in the same plane and has same point of incidence. Same point of incidence. सबके सबका एक ही point of incidence है, and that is point Q in the diagram. So I hope you are clear with the laws, but I am simultaneously doing the two things. I am showing you the reflection from the plane mirror, a normal horizontal plane mirror capped. How does the incident ray will be reflected back in the same medium? That is my point to show. And simultaneously I am teaching you this part also, that what will be the laws of reflection with this diagram. Am I clear? And everybody please make a note of this, that laws of reflection either by plane mirror or either by spherical mirror is one of the same. So no need to worry about it that again you have to write the laws when you are discussing the spherical mirror. No. I thought that while discussing the plane mirror only, I should discuss with the laws also with my diagram. And therefore, once again here, the last you should know that angle I is equal to angle R. That is the first point under laws. That is the angle of incidence is equal to angle of reflection. And second law, that 3 rays which you are talking about in the topic of reflection, the 3 rays which you are talking about, that is incident ray and normal ray and reflected ray, they should be lie in the same plane and they should have the same point. All these 3 rays have the same point of incidence. So if anybody wish to write this, please write it down. This is, I have started with the laws, but now I will show you how does the image will be formed. How does the, I repeat, this is the laws I have written, but now I will show you how does the image is formed by the plane mirror in the case of reflection. If the plane mirror is capped in a different position, I will show you the image formation by the plane mirror with the help of, with the phenomena of reflection. So please write it down, and I am giving you 2 minutes and then we will switch over to the different image formation by the plane mirror. Well, my dear, as I told you that now we will study that how does the image will be formed by the plane mirror in the case of refraction. So let's start with the topic image formation by plane mirror. Image formation by plane mirror. This is the topic. Let us discuss how the plane mirror form the image. But my dear, before that, you should know that we take the two kind of the object. One is the point object. It means the object which I'll take, the object which I'll select looks like a point. It looks like a point. Here I have